Hello students, how are you all? I hope you all are doing well. Myself Swapnil Sir and welcome to yet another video on our vector chapter. Already we have started lecture series on vector chapter. Within that I explained plenty of the videos in my channel. So if you wanted to see similar video, do check in my playlist. So in my today's video, I'm going to explain to you all vector chapter in detail and plus some of the important questions from our vector chapter. That maybe our board exam it is coming closer, okay, that maybe these examples are very much important for your upcoming exam. So let's get start our today's lecture with a vector chapter. First of all, what we do, we go for some of the recap of points. That's just a revision for the point that we needed in our subsequent part of the examples, and then we will move for important questions. Okay, so now let's start our today's lecture with a vector chapter. Okay, now in a vector chapter, basically what we have learned so far, we learn condition for collinearity, condition for coplanarity. After that, we learn when the two vectors are collinear. Okay, when the two vectors are collinear, when two vectors are coplanar, then how can we define the dot product for two vectors, cross product for two vectors. Okay, so all these things we learn here till that. Okay, so we'll go for the little recap about this. Okay, now let me explain first of all what is mean by collinear vector. Okay, collinear vector. So what is mean by collinear vector? Collinear vector. Okay, so collinear vector means, or first of all understand the meaning for collinear lines. Okay, the lines which are parallel to each other or the lines which along each other. Okay, now for example, if I consider the line A to line B, line A to line B, which is a parallel to line B to line C. Okay, so line A to line B, which is a parallel to line B to line C. Okay, both lines are parallel. Both lines are parallel to each other, and when we have two lines parallel to each other, we consider it as the collinear line. Or one more condition, if the lines are along to each other like this way, okay, line A to B and B to C. Okay, now we can see line point A to B, that means we have line segment AB which along with a line segment BC, then we consider it as the collinear line. Okay, so now using this collinearity of condition of a collinearity, we will go for the proof of our section formula for internal division and external division. Okay, which is very much important here for our today's lecture. Okay, and every year there may be one or two questions definitely coming from the section formula. Okay, so do prepare this topic properly. Okay, now collinear lines. Okay, we are going to understand first of all coplanar, and then we move for section formula for internal and external division. Okay, just simple meaning for coplanarity. Okay, the all vector which lies in a single plane. Okay, all the vector which we have here which lies in a single plane, then we consider it as the coplanar vector. Okay, coplanar. Coplanar vector. Okay, the vector which lies in a single plane, then we consider it as the coplanar vector. Okay, there are some other condition. Okay, if we take two vectors are perpendicular, then we can take their dot product 0. Okay, if they're parallel, then there is also some conditions. Okay, so we will use this condition once the examples going. Okay, so what we have to do, first of all, we have to go for the example, and whenever we need the topic while solving example, I will explain that topic detail there. Okay, now what I'm going to explain, if I'm going to explain this topic now here, maybe it is quite confusing to understand. Okay, for you all. Now let's start our today's lecture with some examples. Okay, so before a section formula for internal division and external division, okay, I will explain first of all section formula for internal division. Okay, section formula. Already I have uploaded videos on section formula on my channel. Okay, so if you wanted to see these videos, do check in playlist. Okay, now section formula. So we first of all understand for internal division. internal section formula for internal division. Okay, section formula for internal division means our line segment, any other point, third point which divides our line segment internally, then we consider it as a section formula for internal division. Okay, now see that if I'm consider here, I have line segment A, line segment B. Okay, third point C, which divides our line segment AB in the form of m as to n. Okay, in the ratio as a m as to n. Okay, then we consider the section formula small c bar, which is equal to every vertex is having position vectors. Okay, it is having position vector here. Okay, then m into b bar, m b bar plus n a bar upon m plus n. This one is the section formula for internal division. Similarly, we can do define for external division. Okay, like if we have any third point which divides our line segment AB at externally. Okay, at a point external. Okay, so if it divides externally, then we write the section formula C bar, which is equal to m b bar minus n a bar upon m minus n. Okay, so this one is the external division formula. External division formula. Okay, this one is the external division formula. Okay, so we consider it as the section formula for external division. Okay, that's it only here for internal division and external division of our section formula. Okay, now let's move for some of the examples from our vector chapter. Okay, which are very much important here for upcoming exam. So before we start our examples, we go for understanding section formula for external division. Okay, we first of all plot the figure which having section formula for external division that we have given in our question. Okay, first of all we try to understand that section formula and then we go for the next example. Okay, so we have given here vertices A of A bar, B of B bar, B any 2 points in the space. Okay, A of A bar, B of B bar. Okay, okay, let me go through this one. Okay, so what we have given, A of and B of B bar. Okay, we have two vertices A of A bar, B of B bar, B any 2 point in the plane space. What we have given here, A of A bar, B of B bar, B any 2 points in the space. Okay, B 2 point in the space, and P of P bar, which is a third point we have given. Okay, P of P bar is a third point which divides our line segment AB. Okay, P of P bar is a third point. P of P bar is a third point on a line segment AB. Okay, line segment AB. Okay, that is all things are given in our question. Okay, so all are the given in our statement. Okay, so we have to plot this statement first and then we go for the proof. Okay, P of P bar is a third point on the line segment AB. Okay, dividing line segment AB, but how it divides our line segment AB, which is in the form of external division. Okay, externally. Okay, externally as m as to n. Okay, which divides line segment AB as externally m as to n. And what we have to prove here, P bar, which is equal to m times B bar minus n times A bar upon m minus n. Okay, this is the condition that we have to prove here in our statement. Okay, now let's go for the proof. First of all, we are trying to plot the figure here and then we will move for the our proof. Okay, so let's go for the plotting of a figure. Okay, so now we can see here, so we have given line segment AB, so I drew that line segment AB here. Okay, line segment AB. Now every vertex is having there exists some position vector. Okay, so we will plot that position vector later. And P of P bar, which is a third point. Okay, P of P bar, which is a third point which divide our line segment AB in externally. Okay, so we have the ratios here completely. This one is a n, and consider this one is a m. Okay, this one is the entire value for this one is m, and this one is a n. Okay, now let's go for plotting the next points. Okay, consider now what we have here. We have line segment, which is a division of a third point into the external form. So try to plot the figure, so we can use some another result for finding the section formula for external division. Okay, so some another result, that means we have to use some of the results like a triangle of vector law of triangle of vector addition. Okay, that one be useful here because we want the ratios for their sides. So vector law for triangle law for vector addition is important here. Okay, then we go for taking the ratios for their sides. Okay, now consider any point, another point here O. Okay, so join these vertices here at a point O. Okay, okay, I joined these third vertices here. Again, we have angle bisector of a triangle. Okay, so we can see that I drew here the triangle which is having one vertices O and the point P here. Now we can see that every vertices we do exist a position vector. Okay, so here A bar, here B bar, here P bar. Okay, okay, every vertices it do have position vector. Okay, and now what we do, apply the ratio. Okay, triangle of for vector addition. First of all, take the ratios for their side. Okay, now how can we take the ratios for their side? We can see that segment EB divided by segment PB can be written as m divided by n as the ratios for their side. Okay, so we can write AP divided by PB, which is equal to m divided by n. Okay, once we get the section for ratios for their side, we will apply directly the triangle of for vector addition. Okay, okay, let's go for the taking their ratios. Okay, so we have AB divided by PB. Okay, so this one is the ratio AB divided by. Yes, so what we do for the ratio AP? Okay, so first it goes to the AP, then next goes to the BP. Okay, so we have to very much careful about the sides for their triangle. Okay, because whenever we take the opposite direction, our vectors gives us a negative sign. Okay, so in such a case you need to be careful. Okay, if you are going to change the direction for our vectors, it gives us the negative sign. Okay. Okay, so what we do, we have the third point which divides line segment. So consider this one as the, so what I have done here, I consider the internal division result here. So we don't want that one here. Okay, so A, B here, and P which divides line segment AB externally. Okay, that one we needed here. Okay, so what I have done basically, I divide our line segment P in the form of external division. Okay, so every vertices which is having position vector. Okay, P bar. Okay, now take the ratios for their sides. Okay, so ratios for their side can be written as AP divided by BP. Okay, AP divided by BP. Okay, so AP divided by BP can be written as AP, which is a m, divided by BP, which is a n. Okay, AP divided by m, AP divided by BP can be written as AP divided by BP. So m divided by n. Okay, so this is the ratio I have taken from our given result. Okay, given data. That's it only. Once we get that ratio, just need for a simple calculation after that. Okay, so let's go for the multiplying, cross multiplication. N times AP, which is equal to m times BP. Okay, so n times AP, which is equal to m times BP. Okay. Now see that, apply the triangle law for vector addition on our side AP. Now we can see that AP, that means this is the entire base for our triangle here, that AP can be written as AO plus OP. Okay, AP can be written as AO plus OP. Okay, This one I have written. Okay, so how I have written, now see that vector law for triangle law for vector addition, it says that if you go through this direction for A to P, then you have to add remaining two sides with exactly same direction. Okay, that means AO plus OP, which is the value for AP, similarly which is equal to M into BP, can be written as, now see that BP can be written as, so see here BP here. Okay, so it can be written as a BO plus OP. Okay, BO plus OP. So BP can be written as BO plus OP. Okay, now see that just I have replaced their vectors. Okay, BO plus OP. So now we can see here AO can be written as negative times OA. Okay, so you can write AO as a negative times OA. Okay, it is up to the direction for our sides of a triangle. Okay, so if you change the direction AO to OA, so it gives us the negative value. Okay, so we want the negative as we have given in section formula in the form of negative. Okay, so try to create a negative terms. Okay, so AO can be written as negative times OA, so I can write N times OP negative of. Now see that AO, I can write AO as a negative times OA. Okay, so OP minus OA. Okay, OP minus OA, which is equal to M keep as it is, under bracket OP keep as it is. Okay, so BO can be written as negative times OB. Okay, so what I have done basically here, if I go through the one direction to another place, okay, one place to another place at the same direction, so it gives us a vector positive sign. Okay, and if I replace that same with the opposite direction, it gives us the negative sign. Okay, so need to be careful about the sign of the vectors. Okay, that means negative sign means it represent opposite direction for our vector. Okay, so N times OP minus OA which equal to M times OP minus OB. Okay, so we have these two lines here. Okay, line segment. Now just substitute the value for OP. Okay, OP we have the value for OP is a position vector P bar. Okay, so N into P bar minus OA can be written as OA minus, we can write it as the A bar. Okay, M times, okay, OP can be written as a P bar minus OB can be written as B bar. Okay, okay, this one is our required value. Okay, N times P bar minus A bar, which is equal to M times P bar minus B bar. Okay, now what we do, go for the just multiplication, this term under bracket, you will get the required term. Okay, so multiply under bracket, so N into P bar minus N into A bar, which is equal to M into P bar minus M into B bar. Okay, just multiply N and M under bracket here, and take the terms for P bar together, as we have given P bar which is equal to MB bar minus NA bar upon M minus N. Okay, so what we do, try to take all the terms from P bar at one side and remaining to the other side. Okay, so take the P bar terms at one side, so N times P bar minus M times P bar. Okay, N times P bar, that positive term I have taken here, which goes to the negative of M times P bar, which is equal to N times A bar, take it here, which goes to the positive, that term negative here. Okay, so when it goes to the positive N times A bar, okay, again minus M times B bar. Okay, so M times P bar I have taken, negative M times B bar I kept it as it is. Okay, now what we do here, take P bar common from there, so P bar out here, N minus M. Okay, which is equal to N times A bar minus M times B bar. Okay, take that multiplicand to here, so we'll get the denominator. Okay, so P bar can be written as N A bar minus M B bar upon N minus M, which is our required standard proof for our section formula for external division. Now see that how easy type of the questions are coming in your board exam. That gives us the answer in a 2 to 3 steps only. Okay, I don't think so anything is difficult here in our question. Okay, so even after, if you found anything difficult, let me know in my comment section. Now let's move for the next question. Okay, yes, so in our next question we have given, find the coordinate of the point which divides line segment joining the point A and B externally in the ratio as 1:3. Okay, so what we have to find coordinate of the point. Okay, so our claim here, find coordinate Find coordinate so we want the coordinate of the point. Okay, so we want the coordinate of the point which divides line segment AB. Okay, so which divides line segment AB, which divides line segment AB. Okay, so we want the coordinate which divides line segment AB. So A vertex is given 2 minus 6 8. Okay, 2 minus 6 8, which is the vertices A. Vertices B, it is given minus 1 3 minus 4. Okay, so vertices A and B, both vertices we have given here. Okay, and which divides our line segment AB in the form of external division. Okay, that means we have third point which divides our line segment AB. So we can take that third point here. Okay, which divides our line segment AB as the ratio 1:3. Okay, as the ratio 1:3, and then we want the coordinate of a point which divides our line segment. Okay, so what we want basically here, we want the coordinate of the point. Like a coordinate of point means we want the value for x, we want the value for y, and we want the value for z. Okay, so we have here external division for our point, so we are going to apply the external division theorem here for finding the coordinates. Okay, okay, let's define first of all the vertices, position vector which exist in our vertices. Okay, so what we have given, we have given vertices. Okay, we have given vertices here A 2 minus 6 8. Okay, so we have given vertices 2 minus 6 8, which is the A vertices which exist position vector which is having position vector. Now see that if you consider any vertices in our triangle in our xyz plane, then we know that there always exists a position vector for these vertices. Okay, so for vertices A, there exists a position vector A bar, and which can be written as 2 times I cap, introduce I cap, j cap, k cap here, 2 times I cap minus 6 times j cap plus 8 times k cap. Okay, so I introduce here I, j cap, k cap in the position vector A bar. Okay, similarly go for the vertices B, follow the same process here, B minus 1 3, B vertices we have here minus 1 3 and minus 4. Okay, so vertices B have here which exists a position vector B bar as a minus I cap. Okay, so introduce I cap with a minus 1, j cap with a 3, and a minus k cap with a minus 4. Okay, minus I cap plus 3 times j cap minus 4 times k cap. Okay, so we have given here vertices A and vertices B which exists position vector A bar and position vector B bar. Okay, now we have both of the position vector A bar and B bar which exists to position vector A bar, which exists to position vector B bar, and we have the ratio m:1 like a 1:3 we have given. Okay, now apply the external division formula. So what the external division formula say that here m into B bar. Okay, so m into B bar minus n into A bar upon m minus n, which is the external division for our given line segment. Okay, which is the external division formula for our given line segment. Now what we do, just substitute the value for m and n and position vector A and B in our result. Okay, let's go for the substitution. Okay, okay, so m into B bar. So what we have the value for m into B bar, we know that m we have 1:3, that means 1:3 means m:n. Okay, so m we can write it as the 1 and n can be written as 3. Okay, so we do have these two value m and n which is 1 and 3. Okay, so that means put the value for m which is 1 multiplied by B bar here minus I cap plus 3 times j cap minus 4 times k cap. Okay, this one is the m into B bar minus n into A bar, 3 into A bar which is here 2 times I cap minus 6 times j cap plus 8 times k cap. Okay, this one is here, and completely divided by m minus n, that means 1 minus 3 it is here. Okay, this one is the section formula for external division. I have just applied the section formula for external division and go for the calculations. Then my next step will be minus of I cap plus 3 times j cap minus 4 times k cap. I kept that first position vector as it is because 1 multiplied by any position vector, that position vector remain itself. Okay, minus 3 times. Now what I'm going to do here, I'm going to multiply negative sign under bracket as it is. Okay, so negative 3 multiplied by 2 into I cap, so negative 6 times I cap. Okay, so negative 3 multiplied by negative 6 j cap, so negative negative it goes to the positive. 3 6 the 18, 3 6 the 18 j cap. Okay, negative positive multiplied by negative, 8 3 the 24 k cap. Okay, so completely divided by 1 minus 3, which gives us a minus 2. Okay, this one is our next step. Now what we do, go for the similar calculation, calculation with I cap with I cap, j cap with a j cap, and k cap with the k cap. Okay, so I cap with I cap means minus I cap minus 6 I cap. Okay, minus I cap minus 6 I cap, which gives us a minus 7 times I cap. Okay, plus 3 times I cap plus 3 times j cap plus 18 j cap, so we get the 21 j cap. Okay, so what we are doing basically here, we are trying to add some variable like I cap with I cap, j cap with the j cap, and k cap with the k cap. Okay, minus 7 I cap plus 21 j cap minus 4 k cap minus 24 k cap minus 28 k cap. Okay, so we have minus of 28 k cap here. Okay, divided by minus of 2. Okay, so this one is our required internal division result. Okay, now let's go for the next step of our calculation. So minus 7 times I cap divided by minus 2. Okay, minus 7 times I cap divided by minus 2 we have here. Next minus plus, which goes to the negative, so 21 times j cap divided by 2. After that minus of 28 k cap divided by minus 2, minus of 28 k cap divided by minus 2. Okay, let's go for the next calculation. 7 by 2 I cap minus 21 by 2 j cap. Okay, and minus minus it goes to the positive. 28 divided by 2, that means it is 14. Okay, 14 2s are 28, so we get the 14 k cap. Okay, so we want the coordinate for our third vertices. Okay, so that means we have want the coordinate for our line segment which join externally. Okay, so the coordinate it gives, the first coordinate it goes for the x, second coordinate goes for the y, and third coordinate goes for the z. Okay, so first coordinate, which is a 7 by 2, second coordinate negative of 21 by 2, and third coordinate which is a 14. Okay, so these are the 3 of these coordinate which divides our line segment. Okay, that's it we want here in our example. Okay, so this one is a very much important type of the question. Similar type of the question will get repeated in your upcoming example, so do prepare with this example. Okay, okay, now let's move for the next example. Okay, in our next example we have given a bar, b bar, c bar are the position vector of vertices a, b, c respectively. Okay, now let me write what we have given so far. Okay, so a bar, b bar, and c bar, okay, are the position vector okay, a bar, b bar, c bar are the position vector of a point capital A, capital B, and capital C. Okay, So we have these three position vector capital A with the vertices capital A, capital B, capital C respectively. Okay. Okay, and 2a bar plus 3b bar minus 5c bar, which is equal to 0, which given next line. Okay, so which is a 2a bar plus 3 times b bar minus 5 times c bar, which is equal to 0. Okay, so we have given one more equation here, 2a bar plus 3 times b bar minus 5 times c bar, which is equal to 0. And then we want the ratio in which point C divides line segment AB. Okay, so what we have claimed here, point C divides line segment AB. Okay, so we want here point C which divides line segment AB here. Okay, so we want the point C, third point C, which divides line segment AB, which is the ratio present there. Okay, now what we do, first of all, we have given the equation. Now try to convert that equation whether into the form of internal division or into the external division. Okay, so if we are able to convert this internal or external division, then next part it is easier for finding the ratios. Okay, now always remember that whenever you're going to find the internal or external division, write the formula and try to convert this equation in the internal or external division. Okay. Okay, so we can write m a bar plus n b bar upon m plus n as a section formula for internal division. Okay, and m a bar minus n times b bar upon m minus n as a section formula for external division. Okay, this one is for internal division and this one is for external division. Okay, so we do have those of the section formula, for one is for internal division, another for the external division. Okay, now convert this our equation in the form of internal or external division. Okay, so what we do, go for the adjustment of the term. Now we can see that we have third point C which divides our line segment AB. Okay, that means we can write C which is equal to remaining m a bar minus nb bar upon m minus n, or m a bar plus nb bar upon m plus n. Okay, that means we want one side as a C bar here. Okay, so keep that one side 5 times a C bar as it is. Okay, and remaining terms take it to the other side. So we get the 2a bar plus 3b bar. Okay, so I have taken I kept this term as it is, negative 5c bar I taken to the other side, it goes to the positive of a c bar. Okay, then c bar can be written as 2a bar plus 3 times b bar upon 5. Okay, so 5 it is multiplicand here, it goes to the denominator here. Okay, let's go for the next c bar. Okay, so we can see that m a bar plus nb bar upon m plus n as the part of a denominator. That means 2 times a bar plus 3 times a b bar upon 2 plus 3 as a section formula for internal division. Now compare this section formula for internal division with our given example. Okay, so we can see that 2 into a bar, that means 2m into a bar plus n into b bar upon m plus n. Okay, this one is a section formula for internal division. Okay, so we can say that m as to n, we get it here 2 as to 3. Okay, that means value for m is a 2 and n which is equal to 3 here. Okay, so that's it here, the value for m and n as per our given data. Okay, so that's it. We want here our point C which divides our line segment AB in what a ratio. Okay, and that ratio I found here 2 as to 3. Okay, now let's move for the next example. Okay, we have given 4 vertices, capital A, capital B, capital C, capital D. Okay, A, B, C and D are the 4 vertices which given for our okay, and all these vertices are non-collinear points. Okay, A, B, C, D all are the non-collinear. Okay, all points are non-collinear, that means all are not parallel or not along. Okay, all are the non-collinear, all are the non-collinear point. Okay, such that AD bar plus B times D bar plus c times d bar, which is equal to 0. That is we have given here, okay? And then the point D is a centroid of a triangle ABC, okay? Centroid means, what is mean by centroid? Let me explain first of all the centroid in simple language, okay? So if we take any angle bisector of a triangle, okay? Angle bisector of a triangle which meet at some certain point, okay? So we have three angles for our triangle, okay? And from every angle bisector of a triangle, if we draw one median, which divides at a same point, okay? Three of these angle bisector of a triangle divide at a same point here. So we consider this one as the centroid for our triangle, okay? Now we can see here, if we go through like a visualization, so we can see that this first angle bisector of triangle, let's go for the another angle bisector of a triangle, and third, which is the angle bisector of a triangle, okay? The point which coming here for middle, which is considered as, which we consider as a centroid for our triangle, okay? So this one is a triangle, and triangle ABC which having centroid, okay? So consider we have the ABCD are the four non-collinear points, okay? And AB, BD, CD which is equal to their addition, which is equal to 0, okay? Then we have to show that D is a centroid for our triangle ABC. That means we can write D which is equal to remaining addition for three vertices, okay? A bar plus B bar plus C bar divided by 3. That condition we have to prove here, okay? Which we call it as the centroid for our given figure, okay? Yes. Now we can see that position vector ED bar, okay? Sorry, vector ED bar can be written as the position vector D bar minus position vector A bar, okay? So AD bar can be written as, now see that this one is our standard form. AD bar can be written as a D bar minus A bar in our vector form, okay? So that same we have to apply here subsequently. AD bar can be written as D bar minus A bar, okay? Plus BD bar can be written as D bar minus B bar, and plus CD bar can be written as D bar minus C bar, which is equal to 0, okay? So what I have done basically here, I just written AD bar as a D bar minus A bar, okay? After that BD bar as a D bar minus B bar, and CD bar as a D bar minus C bar, okay? Now let's go for the next calculation. Remove this bracket, D bar minus A bar plus D bar minus B bar plus D bar minus C bar, which is equal to 0, okay? Now say that take all the negative term together, all D bar together, and go for the first, further calculations, okay? Now let me change the color, yeah. So we can see that this D bar plus this D bar plus this D bar, okay? So we got the 3 times D bar, which is equal to, so keep that equal to for next step, okay? 3 D bar. So I have added D bar 3 times, okay? D bar plus D bar plus D bar, which is a 3 D bar. So negative A bar, negative B bar, negative C bar, okay? Which remain negative A bar, negative B bar, negative C bar, which is equal to 0, okay? This one is our next step, okay? Now let's go for the next step. So 3 D bar keep as it is. Take negative common from this entire 3 terms. So we get the A bar plus B bar plus C bar, which is equal to 0 here, okay? So 3D bar minus of A bar plus B bar plus C bar, which is equal to 0, okay? Now what we do, take that negative term to the other side, it comes to be the positive. So we write it as the 3 times D bar, which is equal to A bar plus B bar plus C bar, okay? A bar plus B bar plus C bar, okay? And as we know that a centroid formula for our triangle, it says that we add 3 of these position vector and divided by 3 here, okay? So take that 3 to the other side. So we can write this one as D bar, which is equal to A bar plus B bar plus C bar divided by 3, our required section centroid for our given vertices A, B, C, D, which are the non-collinear, okay? So that's it we want here in our proof, okay? I'm expecting that you all have understood. Nothing it is difficult here. Just need to go for a little bit calculations and need to know only basic 1 or 2 conditions from our vector chapter, okay? I'm expecting you all have understood. Now let's move for the another example, okay? So in our next example, we have given position vector P bar, Q bar, okay? These are the position vector of a point PQ, and we have to find the position vector point R, which divides line segment PQ internally in the ratio as a 2:1, okay? So what we have to do, basically we have to apply here section formula for internal division, okay? And section formula for internal division, when we have ratio m as to n, then we define section formula for internal division as a m into A bar plus n into B bar upon m plus n, which is the section formula for internal division. Okay, now let's apply this section formula here and go for the further calculations. Okay, so we have given position vector p bar as a I cap minus 2 times j cap plus k times k cap. Okay, and position vector q bar is also given. Okay, position vector q bar, it is also given position vector q bar also given I cap plus 4 j cap, I cap plus 4 times j cap minus 2 times k cap. Okay, so we have given position vector p bar and q bar there. Okay, are the position vector of a point pq. Okay, are position vector of p and q. Okay, of a point p and q. We have given position vector of a point p and q as a position vector p bar and q bar. Okay, and we have claimed here we have to find out the point r which divides line segment pq in the form of internal division, which is a 2:1. Okay, yes, now what we do, we have the ratio given m as to n. Okay, ratio what we have given, ratio for division of this line internally. Okay, ratio for internal division, ratio for internal division we have given m as to n means 2:1. That means m we have here 2 and n we have here 1. Okay, so these are the required conditions we have given in our theorem. Okay, now apply these results conditions in section formula for internal division, you will get the required answer. Okay, now just need to the substitution. Okay, yes, yes, now we can write it as the m into q. Okay, and n into p. Okay, so we can plot if you want the figure. Okay, so consider this one is m as to n. Okay, so m into consider it as the p here, and this one as the position vector q bar. Okay, so we have position vector p into q. Okay, yes, so we have given position vector q bar, position vector p bar, and internal division of a line segment m as to n. Okay, now let's write the section formula for internal division. As we have the ratio for section formula for internal division, so we can write m into q bar. Okay, plus n into p bar divided by m plus n, which is a section formula for internal division. Okay, now substitute the value for m and n. So we have m which is equal to 2, n which is equal to 1, and p bar we can write directly as the position vector p bar and q bar here. Okay, so m which is a 2 into q bar which is a I cap plus 4 times j cap. Okay, minus 2 times k cap. Okay, yeah, 2 into q bar. Okay, 2 into q bar here, that means m into q bar plus n into p bar. Now what is the value for p bar? N we have here 1 into p bar, I cap minus 2 j cap plus k cap. Okay, I cap minus 2 times j cap plus k cap. This one is our second position vector divided by m plus n, that means a 2 plus 1 we have here. Okay, and what we want always remember here we have to go. Okay, we want here the position vector of a point r which divides line segment pq. Okay, internally, that means we want that third point r given here, which is the position vector r bar, we want that one here. Okay, so let's move for finding the position vector. Multiply 2 under bracket and at the end go for the subtraction addition of their similar variables. Okay, so 2 into I cap plus 8 into j cap minus 4 into k cap. Okay, multiply 2 under bracket 2 into I cap plus 8 into j cap. Okay, minus 4 into k cap. Okay, plus I cap minus 2 j cap, I cap minus 2 j cap. As we have 1 multiplied by position vector, that position vector remain itself. Okay, so I cap minus 2 j cap plus k cap. Okay, so this one is our numerator. Upon 2 plus 1 we can write it as the 3. Okay, so 2 I cap plus I cap we can write 3 times I cap. Okay, 8 j cap minus 2 j cap we can write plus 6 times j cap. Okay, minus 4 k cap plus k cap we can write minus 3 times k cap, completely divided by 3. Okay, Now go for the separate division of our line segment. So 3 I cap divided by 3, okay, 3 into I cap divided by 3 plus 6 j cap, 6 into j cap divided by 3 minus 3 divided by 3 into k cap, okay. So 3 divided by 3, which is a 1 I cap, plus 6 divided by 3, which is a 2 times j cap, minus 3 divided by 3, which is 1 into k cap, okay. This one is our required r bar, okay. This one is our required position vector r bar that we want here in our question, okay. Now see that how easy this type of the questions are. Just we need to think little bit logically that to get the answer, okay. So I'm expecting you all have understood this solution. Nothing it is difficult here. Now let's move for another example, okay. In our next example, we have given a bar, b bar, c bar are the position vector of a point capital A, capital B, capital C, okay. So capital A, capital B, capital C, these are the vertices we have given. Small a bar, small b bar, small c bar are the position vector here, okay. These three are the position vectors, okay. These three are the position vectors, okay, such that we have given 3 times a bar plus 5 times b bar minus 8 times c bar, which is equal to 0 given, okay. And we want the ratio in which a divides line segment BC, okay. What we want? Ratio a divides, okay, divides, okay, ratio a divides, okay, let me go for it again. Ratio a divides, okay, divides, okay, line segment BC, ratio a divides BC, okay, line segment BC. We want the ratio a which divides our line segment BC, and we don't know here whether it is dividing our line segment BC as a externally or internally. That we have to figure it out, okay. So how we can find this one? First of all, we go for the finding external division or internal division by using our given equation, okay. Now apply the external internal division result over here, okay. So we can see that a bar, b bar, c bar are the position vector, okay. Now we want the ratio in which a divides line segment BC. That means a divides line segment BC. That means a is the midpoint here for line segment BC, okay. That means we cannot consider as a midpoint, but a is the point which divides line segment BC here, okay, maybe internally or externally, okay. So that means we want the point in the form of a, okay. So in the form of a, so we can write a as a 3 times a bar can be written as 8 into c bar minus 5 times b bar, okay. So what I have done here, I taken that positive 5 b bar here, it goes to negative 5 b bar, and negative 8 c bar, it goes to the positive 8 c bar, okay, which is equal to 3 times a bar. So we can write a bar as a 8 into c bar minus 5 times b bar divided by 3, okay. So 3, it is a numerator multiplicand here. Take it to the other side, we will get the it is as that part of a denominator, okay. Now let's move for the next. We can write this 3 as a, so now we can see that we have the numerator as a sign of a negative sign given there in numerator. So similarly we have to convert that denominator into the negative sign, so we can directly apply the section formula for external division. And section formula for external division, it says that if our line segment AB which divides third point C in the form of external, or it is an external division, then we write section formula for external division as a MB bar minus NA bar upon M minus N, okay. So let's write 3 as a in the form of 8 and 5. So we can write a bar which is equal to 8 into c bar minus 5 times b bar upon 8 minus 5. So I have written 3 as a 8 minus 5. So compare this as a bar which is equal to m into c bar minus n into a bar upon consider n into b bar upon m minus n, okay. So we can see that here m as to n we have ratio 8 as to 5, okay. That means m which is equal to 8, okay, and n which is equal to 5. We have these two ratios here in our given solution, okay. So that's it. We want here find the ratio of point A which divides line segment BC, okay. So the ratio for A divides line segment BC, which is 8 as to 5. Okay, that's it, our required answer. Okay, I am expecting that you all have understood this solution. Nothing we have here, just need to apply the section formula for external division here. Okay, let's move for the next example. Okay, so in our next example, we have to prove using vector method, find the incenter of the triangle whose vertices P040, Q003 and R0, okay, R043. Okay, so similar type of the example we already solved it here. Okay, now what we do here, first of all, we are trying to convert our vertices in the form of position vector. Okay, now at a point P, now we see that here we have point P given 0, 4 and 0. Okay, point P given 0, 4, 0. Again point Q given 0, 0, 3 and point R given 0, 4, 3. Okay, so we have 3 of these vertices we have given here, and we know that there exists, every vertices there exists one position vector. Okay, so with the vertices P we have position vector P bar, with the vertices Q we have position vector Q bar, and with the vertices R we have position vector R bar. Okay, that means we write it is in the form of I, J and K. Okay, that means 0 times I cap plus 4 times J cap plus 0 times K cap, which is our first position vector, which is a P bar. Similarly, we can write 0 times I cap plus 0 times J cap, okay, plus 0 times 3 times K cap. It is not a 0 because we have third vertices which is given 3 times K cap, okay, plus 3 times K cap here we as the second position vector. Now third position vector R bar, which is equal to 0 times I cap plus 4 times J cap plus 3 times K cap. Okay, okay, 3 of these we have the position vector which exist here. Okay, P bar, Q bar and R bar. Okay, yes, now using these 3 position vector we have to plot, okay, the triangle. Now we can see that the vector method, okay, triangle which is having vertices we have here, which is the first P, second Q and third which is R. Okay, and every vertices we have a position vector P bar, Q bar and R bar here. Okay, 3 of these are position vertices and which is having different 3 position vectors. Okay, yes, and what we want the incenter of the triangle. Now go for the finding the incenter as we have done in our previous example. It is similar example like this one. Okay, so I'm keeping this example for you all just for your homework, and let me know the answer in my comment section. So if you found anything difficult, let me know in also my comment section. Okay, I will come up with a similar video. So, and if you wanted to learn some new topics, new concept in mathematics, do comment in my comment section. I will come up with the similar type of the videos. Okay, so I hope you all have understood everything from my today's lecture. Now in the last session of my lecture, so what we learned so far in our today's lecture, we go for just recap. Okay, so in our today's lecture we started with the position vectors, okay, direction, cosine, direction ratios, position vectors for our line segments. Okay, so after that we have learned section formula for internal division and external division. Okay, for our given lines. Okay, section formula, how it define for internal or external division. Okay, after that we learn for the condition for coplanarity, condition for collinearity. Okay, this condition we have learned here. After that we learn one of the important theorem which is a section formula for external division, and subsequent part we applied some of the example, we have taken some of the example which based on a section formula for internal division and external division. Okay, so I'm expecting that you all have understood my today's lecture. Okay, even after if you found difficult, let me know anything in my anything difficult, let me know in my comment section. Okay, I will come up with a similar video. So thank you everyone, thank you for my today's lecture.